And now we have some comparison properties for the integral. Hopefully, number 6 makes sense to you. If the function f is above or maybe touching the horizontal axis between a and b, then the amount of area under the curve is going to be positive, or maybe 0 if the function is just the x-axis. Number 7, again, I hope this makes common sense to you. If f is at or above g on the interval from a to b, then the amount of area under f has to be at or above the amount of area under g. So again, I hope that makes common sense to you, and if not, just let me know. Now, number 8 is a little more complicated, and we have a picture to go with it. So first of all, if m is less than or equal to f is less than or equal to cap m, what does that mean? So this function, f of x, is bounded at its highest point by cap m and its lowest point by little m. So it exists entirely in between. All the y values on f are entirely in between little m and big M on this interval from a to b. Then it says the amount of area under f of x between a and b is in between these two quantities, little m times b minus a and big M times b minus a. So what does that mean? All right, so let's first of all look at little m times b minus a. That's actually this area of this rectangle right here. This area is height, little m, times width, b minus a. So this is just a rectangle with height m, little m, and width b minus a. The cap m times b minus a. Right, so actually, here, let me relate that. The cap m times b minus a is this purple enclosed rectangle. And so again, that is just cap m times b minus a is the area of a rectangle. So here is a rectangle whose area is height, cap m, times width, b minus a. And what the property says is that the amount of area under f from a to b is in between those two. So let me use this other picture. The actual amount of area under f from a to b is given by that integral. And again, when we say the area under f, we mean the area between f and the horizontal axis. So all of this area underneath f is the integral of f of x dx from a to b. And so what that property says is that this red shaded area, the integral of f of x dx from a to b, also known as the area between f and the x-axis, between x equal a and x equal b, that amount of red area is in between the blue area, little m times b minus a, the area of a rectangle there, and the purple area, the area of the big rectangle. Okay, so again, hopefully you can see that, and I didn't make it too busy. So remember the premise of this. The function f of x has to be bounded, so you look at the lowest y value and the highest y value that little f takes on in that interval from a to b. And then you can finish off the rest of the property, but it has to start with f being bounded by little m and big M. Now, at the bottom of this, it says to read section 4.8 carefully and thoroughly. This semester, I actually gave you some videos and notes for section 4.8 before we started chapter 5, or as a prelude to chapter 5. But either if you haven't done it or if you need a little refresher, you could certainly go back and look through that again. But we're going to need that coming up.